Today, our presentation topic is logical and physical address. And welcome to our presentation. My ID last four digit is 1120. We are a group of students from the operating system course, and today we will presenting an important topic: logical versus physical address space. We hope this presentation helps you clearly understand the concept and its importance in modern memory management. Here is our team members. Navigating memory, logical versus physical address space. Today we will delve into a fundamental concept in operating system, the distinction between logical physical address space. We will explore now modern system manage memory, enabling complex applications to run efficiently. Then introduction to address space. I will begin by defining logical and physical address. A logical address is generated by the CPU during program execution, acting as a virtual reference in constant. A physical address refers to an actual location within the main memory RAM. This distinction is crucial for understanding memory management. Assalamu alaikum. My name is SK Said. These logical addresses from the logical address space, while their physical counterparts constitute the physical address space. Throughout this presentation, we will explain why the logical address space can often be significantly larger than the physical one, examining both its advantage and disadvantage. My next team member, Moriam Jahan Ritu, will continue from this.
Assalamu alaikum. Myself Moriam Jan. Last four digit of my ID 1126. Today I am explaining two important topic: logical address space and virtual memory. First I will talk about logical address space. Logical address space is the range of addresses generated by the CPU during program execution. These addresses are virtual and do not directly represent physical memory. The memory management unit, or MMU, converts logical addresses into physical addresses. Second, why logical space is greater than physical space. Now I will explain why logical address space is greater than physical space. This happens because of virtual memory. The operating system uses secondary storage like hard disks or SSD as an extension of RAM. So the CPU thinks it has more memory than actual installed. Thirdly, the virtual memory advantages. Next, I will talk about the advantages of the virtual memory. Virtual memory allows program to use more memory than physical RAM. Virtual memory, it supports multitasking by running multiple processes at the same time. I also gives flexibility to develop, so to create a larger application. In conclusion, logical addresses, space, and virtual memory help improve memory efficiency and system performance. Now, I'd like to invite my another team member for explaining another part of the slide.
I am Zakari Habib Nihad. My ID is 1827. Now I will talk about the disadvantage, which is perform overhead. The main problem comes from slower disk access. RAM is very fast, but disk is much slower. When the system needs the data that it's not RAM, a page fault happens. This means the system must get the data from the disk. This takes more time. If page fault happens, often the whole system becomes slower. As a result, program respond more slowly and user experience is worse. So there is always trade-off between having more memory space and keeping good speed. Next, larger logical addresses space helps the system use memory more efficiently. Program can still run even when physical RAM is limited. It also allows main process to run at the same time without running out of memory. This makes the system more stable and smoother to use. Because of this, efficient memory utilization is key feature of modern operating system. Now, my next teammate will continue.
Hello, Assalamu alaikum everyone. My name is Nirav Shaharajan. The last four digit of my ID is 1532. First of all, I would like to thank my honorable teacher and my team members to help me in this presentation. So, in this presentation, my topic is trade-off, capacity versus speed. Here we can see there are two types of memory capacity and performance speed. We can see there are two parts of memory capacity. One is virtual memory, one is expanded addressing. Another one from the performance speed is page faults, and another one is reduced through output. Conclusion, key takeaways. First of all, we can see the logical versus physical. Logical address space is virtual, generated by the CPU. Physical address space is the actual RAM location. Second is virtual memory. Thanks to virtual memory, logical address space can be considerably larger than physical memory, utilizing secondary storage. And the third one is benefits and cost. This offers immense benefits uh, running a large program, but introduces performance overhead due to slower disk access. Understanding this fundamental difference is vital for appreciating how modern operating systems efficiently manage limited memory resources to provide a seamless computing experience. Next slide, please. So thank you. We have now reached the end of the presentation on logical versus physical address space. Thank you.
Thank you.